It's recorded. Okay. Good morning, everyone. Thank you for being here. Let's start our session this morning with Surah Al-Fatiha and the morning prayer. Al-Fatiha. Ameen. Alhamdulillah. Okay. How are you this morning? I hope everybody is doing fine. Thank you for being here on the Saturday morning. Yeah. We try to do it quickly so we can finish early and then go out shopping. Dah ada orang nak shopping. Okay. What else? I have made Muhammad Fikri as a co-host. Yeah. Paksa rela je. So please help me to mute participants if anybody accidentally on their mic, yeah, or need to be let in. Because today I am a soloist, yeah. Tak ada, I think Dr. Nurhayati, ada Dr. Nurhayati ada, yeah. But it's going to be very informal, yeah. So today is our last and final AE clinic for this semester, yeah, for you guys to help you with, especially today the topic is on quantitative analysis, yeah. So let me share the slide first. Okay, can you see the slide? Okay. Give me some feedback. I can't see you anymore. Okay, boleh nampak slide? Hello.
Yes, doctor.
Okay, thank you.
Boleh.
Okay, yeah, boleh, yeah? Right. So as I said, let it be informal. If you have any questions throughout my talk, please just ask questions, yeah, or you can type in the chat box. But as I progress with my talk, I can't see the chat box now, so maybe somebody can read for me if there is any question in the chat box, yeah? Okay. Right, so quickly, let's talk about statistical analysis using SPSS. Yeah. So this is especially, I have also invited postgraduate students, yeah, for your information. This is for final year students, undergraduate, yeah. They have to do their final year project paper. It's called academic exercise, EDU 650, yeah. So although it's designed for the undergraduates, but I am sure statistical analysis can be used for all level, yeah, master and PhD also, if you are here to gain some knowledge on how to do it. I will not use any software today. I mean, as SPSS as a live demonstration is all in the slides, yeah. So later we will upload this slide and the recording in Google Drive, yeah, assigned for academic exercise, and you can feel free to listen to it and refer to my slides later. So in this clinic, yeah, or in this workshop, yeah, I will start first, of course, with some advice, pep talk for you, and then the outline of research report, which is basically a standard format, yeah, for all level, undergraduate or postgraduate, and then some basics of quantitative data analysis, and then we will go into analyzing data and how to interpret it, yeah, for your chapter 4. Okay, pep talk first, yeah. For the AE students, remember you have only 4 more weeks, yeah, to submission date, which is on 14th of July, yeah. 14th of July. So I counted this morning, 4 more weeks. Students are to submit their soft copy to the supervisors, And then supervisors have about 1 week to return back with feedback. Yeah. And 28th July, you have to submit the final project paper to your supervisors, because we need 1 or 2 weeks to read and give you the final marks. Okay, so please put this in your calendar. I hope you have contacted and worked well with your supervisor. Yeah, please do so. It's still not too late. Yeah, to say a hi to your supervisor if you have not been in touch. Yeah, say sorry and say that you have been in trouble if you have not contacted your supervisor before. Yeah, don't just tiba-tiba selepuk je kasih 5 chapters. Yeah, don't just give all the chapters without showing your supervisor that you have done the work with him or her. Yeah. And whatever issues you have in relation to completing your AE, please do so. You can talk to your supervisor. You can talk to me or Dr. Nur Hayati as the coordinator. Yeah. If you have any problems with writing, either chapter 1, 2, 3, 5, or with analyzing data, especially quantitative, you can always contact me, no problem. Yeah? Even though you are not under my supervision, inshallah, I will help you. Yeah? If I can lah. So a disclaimer, I am not a statistician. My background is counseling and educational psychology. So there are lots of things I do not know about statistics, but because of the software SPSS, I learned to use it, and I learned to know about some basics lah, of analyzing, interpreting, and writing the result. So that's why, and I like it. So I find it easy to guide and help students if they don't understand. But if you ask me questions and I can't answer, then I will refer you to another colleagues who are more knowledgeable about statistics. Okay, a reminder of the chapters in your research report, AE or thesis or dissertation is the same thing. Yeah, we have basically in UITM 5 chapters. Yeah, so chapter 1 to 3 for the undergraduate students. Remember, this is your proposal chapters. A reminder to please change your tenses. Yeah, when you write your proposal, it's all in like future tense. The researcher will do this, the researcher will do that. Yeah, but when you submit for your final semester, make sure you change all the future tense to past tense, because you have already conducted the study now. Yeah. So, and today we will talk about chapter 4, basically, how to write the results. And I hope we have enough time to cover a little bit of chapter 5. Yeah. Okay. So basically, how to write your chapter 4. Yeah. Especially this is for quantitative, but with qualitative, the format or the flow is about the same. Yeah. You begin with 4.1 introduction, just one short paragraph, to introduce the chapter. Remind readers what are your research objectives, and then tell readers what you are going to present in this chapter, all in a paragraph. Yeah, and then you go to 4.2 demographic findings. Yeah. Which is a must. Whether you are doing quantitative or qualitative, you must have a section on who are your respondents, and that is called demographic findings. So make sure in your survey or in your observation or in your interview session, you ask your respondents for basic details like their age and gender, of course, workplace experience, yeah, level of education, or whatever things that you think can describe to the supervisors or the readers who your respondents are. And the flow with presenting results, yeah, is basically the same. You have a table or a graph, yeah, first, and if doing quantitative is the transcription, and then you describe or explain your data. So if you can see in the sample here, yeah, you have one table and then a short description. Yeah, you have one figure and description or explanation underneath. If you are doing qualitative, the same thing. You have your excerpts from the interview, yeah, quotation or whatever, and then you follow with a paragraph or two explaining or interpreting your data. Yeah? So this one is a short paragraph because it's demographic. With demographic details, you don't have to explain too much. Yeah? You just describe the numbers and percentages of presented in the table or the diagram or charts. Yeah? Okay. Then you have 4.3. Yeah, I recommended that students write their chapter 4 using this format. Yeah, list your research questions. Remember to copy paste. Yeah, copy paste the research questions that you have in chapter 1. Don't rewrite it. Why? Because when you rewrite your your research questions, yeah, sometimes you tend to rephrase. Yeah, tiba-tiba je sometimes you suddenly you say, I think I should rewrite this, or just one simple word you find a synonym for it. Yeah, but you don't you are not aware that you have slightly changed, yeah, your research questions in chapter 4 compared to chapter 1 or 2 or 3 if you repeat it. Yeah, so that's why the best way is to copy paste. Yeah, don't rewrite. Yeah, so you do like this. Three subtitles, yeah, or 4 subtitles depending on how many research questions you have. You can directly copy paste the research questions or research objective, up to you. Yeah, keep it consistent, or you can make it into a subtopic. Yeah. For example, instead of what are the healthy lifestyle practices of adolescents in Shah Alam, for example, you put a subtopic, healthy lifestyle practices of adolescents in Shah Alam. Yeah, so it becomes a subtopic. Can also. And then again, the format is what is your data? Present it, then describe your data, and then interpret your data. Yeah, I will show you an example of how to write this section. Yeah. So you go on to research question 2 and research question 3, and then finally your conclusion. Again, a short paragraph on summary of what you have found in your data analysis. Right? So this is the outline for chapter 4, especially quantitative write up. Yeah. Again, qualitative pun can follow this outline. Right, let's look at, yeah, before we go into data analysis, the real one, let's look at some basics of quantitative data analysis. Yeah, this will be like a repeat of your statistic class. Remember, EDU 541, yeah, basic data analysis. Okay, so we will talk about types of statistics, types of data, and matching your RO with hypothesis and type of data. This is all important because in using statistics, yeah, you need to know what kind of data you have so that you can match it with your type of analysis. Okay. I hear mine also. Is there any question? Just interrupt me if you have any question. Yeah, I am okay. Or maybe Shazwani, yeah, Nurul Shazwani, Wani can help me to read any question in the chat box if there is any. Wani,
Okay, I will, Doctor.
okay, thank you. All right.
Okay.
Some basics of statistics, yeah. A review. There are two types of statistics, yeah, descriptive and inferential. Yeah, so descriptive, if you are just summarizing your data, and you can use tables or charts, yeah, to present your data. Yeah, with descriptive statistics, you are not interpreting anything. Yeah, that's why, as I said, in demography, how many males, how many females, for example, in your study, you just describe it. Yeah, you don't conclude like, oh, therefore there is more males and females in the population. No, no need. Yeah, you just describe. But with inferential statistics, yeah, this involves using sample data to draw conclusions about a population. Yeah, remember when we talk about the target population, yeah, who are your research population? First, you want to take a small sample that should be representative. Yeah, the word is representative, mewakili. Yeah. So that's what random sampling is about, yes, sampling technique. If you are doing quantitative, but if you are doing qualitative, representative samples is not a must, right? Why do you want to have representative samples in quantitative? So that when you have the data and you analyze, the result can be generalized back to the target population. So whatever data you take from a good sampling technique, it can be generalized to the population, the target population. Therefore, your conclusion, yeah, when you make conclusion, you can say, you can generalize lah, yeah, your result. Okay. When you talk about descriptive statistics, yeah, there are various ways of doing it. Yeah, first one is summary statistics that summarize using numbers. Yeah, so you can use distribution of values or scores. Yeah, which is called measures of central tendency. Yeah, such as mean, mode, and median. Okay, maybe you recall the names here. Yeah, mean, mode, and median. Or you can talk about measures of dispersion. Yeah, to describe the spread of values in the data set. For example, you use standard deviation, variance. This is especially suitable if you are describing test performance, yeah, scores of marks. You will need all these measures of dispersion, yeah. Now you can just use a mean, frequencies, and so on. You can also use graph, okay, to visualize the data. Is very helpful. That's why in a minute I will show you example of when you write your demographic. This is where you can choose, instead of putting a table, change it into a graph, yeah, pie chart or bar chart, yeah, histograms, stem and leaf, scatter plots. All these are types of graph, yeah. But remember, yeah, one presentation of data, only one type of display. Yeah, maksudnya meaning if you use table, just use table, one table for that particular data. Yeah, don't put a table plus a diagram. Yeah, don't put a table plus a pie chart to describe one data. That is not right. Yeah, no need lah, no need. Yeah. So just choose one kind of presentation. So here you go, tables. Yeah, table can help us understand how data is distributed, and we can see the numbers here of frequency table or mean and standard deviation. Yeah, so these are examples of descriptive statistics. If inferential statistic, I will let you read this. So in short, yeah, depends on what you want to find out, yeah, in your research questions. You may want to find the relationship between two variables, yeah. So there are two types of inferential. Yeah, inferential is higher statistics where you can make conclusion, yeah, based on your data. There are two types of inferential statistics: parametric test and non-parametric test. Yeah, you can refer back to your statistic books what this is all about. Basically, let me wait, let me go. I have it in my notes. Yeah, you can see there. Yeah, parametric test assumes the value are normal. Yeah, it's about normal distribution like this. Yeah, normal distribution, or is your data skewed or not? So especially for PhD and master students, yeah, PhD, you need to study whether your data is normal or not, because it affects, yeah, what kind of statistics you can use. Okay, so if you want to do relationship, yeah, your data is okay, normally we will use Pearson correlation, yeah. If not, you can use Spearman test. If you want to compare between groups, between two groups, independent sample t-test, if you have pre and post, catch sample t-test, yeah. If you have more than 3 groups, compare, then it's ANOVA. Okay, so all this I will explain later, and in this workshop I will just go with parametric test. Yeah, non-parametric I will not share today. Yeah, you can try on your own. Okay, so non-parametric, Mann-Whitney test, Wilcoxon test, Kruskal-Wallis test. Yeah. And finally, if you are doing prediction, yeah, the effect of, yeah, can X affect Y, for example. If parametric, you use regression, yeah, whether simple regression or multiple regression. Okay, so it all depends on your research questions. Okay, and the next thing that you need to understand when you want to use statistic is the types of data. Yeah, remember, data can be, of course, in numbers. Yeah, and the numbers can be quantitative. Yeah, called ordinal, nominal, interval, or ratio. Yeah, do you still remember? Yeah, basically, okay, let's look at this. Okay, just to make it simple for you, there are 4 types of data. Yeah, nominal, ordinal, interval, and ratio. What is on nominal? Nominal is categorical data. Yeah. To simplify, for example, in your survey, yeah, when you have variable, yeah, gender, and the answer, the options is category, male or female. Yeah. Race, for example, Malay, Chinese, Indian. Yeah, or class A, B, C. Yeah, so categorical is called nominal. Yeah, there you go, nominal. If your survey or variable is give the options of still nominal, but there is a sense of ranking. Yeah, high and low order. Yeah, order. The word is order, so the name is ordinal. Yeah. So low, moderate, high can be categorical, but there is a sense of low is lower than high. Okay. Ataupun or A, B, C, then A is higher than C. Yeah, if you have that sense of data, it's called ordinal. But basically, the type of analysis for nominal and ordinal is similar, yeah, because the concept is categorical. Compared to the other two, interval and ratio, yeah, the best way to remember is it is raw numbers and it has decimal point, yeah, titik perpuluhan. Okay, for example, test score, yeah, when you write open-ended here and you ask your respondents to write their test scores, marks, or CGPA, yeah, instead of CGPA, you give a range of 10. For them to take their range, you ask them for the specific numbers. Yeah? So that can be analyzed using statistic that is suitable for interval or ratio. Yeah. Um, and this is rating scale. I'm sure you have seen this before. Yeah. So this is raw numbers actually 1, 2, 3, 4, 5. Yeah. If you treat it as interval or ratio, you can analyze this using mean. And instead of frequency 1, 2, 3, 4, 5 for your uh, rating scale, you want to analyze it using mean. Yeah. Or if you want to compute, for example, 5 items into one score, yeah, that is also mean and standard deviation, yeah, interval and ratio. Okay, so uh, for non-statisticians, yeah, for layperson, I always say to my students, interval and ratio have decimal points or is raw numbers, yeah. Nominal and ordinal is categorical. Okay, right. And you also finally, yeah, not finally, but basically you need to understand, yeah, when you want to do quantitative analysis, it's very important to get your research objective and research questions right from the start because it kind of determine, yeah, the statistics that you will use. Yeah? So I have here all written for you. Yeah, the purpose of analysis and how to write your objective and how to translate it to research question, whether you need hypothesis or not, and then what kind of statistical analysis. But of course, again, this is just parametric. Yeah, if you have what kind of data. Yeah, so in short, you can see if you want to describe, just describe, yeah, the level of, for example, to determine the level of motivation of students in learning something. Yeah, uh, this is objective, yeah, to determine or to specify or to measure or to investigate. Yeah, so the verb here is kind of important also to show that this is quantitative. Yeah. Then you transform it to research questions. Yeah. So here also my suggestions is you copy and paste. Yeah. Copy and paste objective to research question and turn it into a question. Yeah. Do not rewrite because again, when you rewrite, yeah, you tend to make changes to the words and it will become a different thing. Yeah? So this is not the time to be creative, yeah, and innovative in your writing. Objective and research question is very technical thing and it must be matching. Yeah, the same thing, not tiba-tiba suddenly objective different, research question sounds different. Yeah, so it's best to just copy paste. And if you just describe something, yeah, you don't need any hypothesis. Yeah, there is no hypothesis if you just describing something. Remember, yeah. Okay. Now, if your data is nominal or ordinal, then it's best to use frequency and percentage. Frequency, the friend is percentage. In bahasa I say frequency, kawan dia percentage. Kalau mean, kawan dia standard deviation. Mean, the friend is standard deviation if your data is interval or ratio. Okay, so this is where you can see the matching of type of data and the proper statistical analysis. If not, it will look wrong in the eyes of readers who understand. If you don't understand, of course, the SPSS will just analyze for you and you present it, but it will be wrong, not the suitable analysis because you have not observed the right types of data. Okay, descriptive, no hypothesis. Right, if you want to compare, there are several types of comparison. First, if you want to compare between two groups, for example, you want to compare performance between male and female, two groups. So when you translate to research questions, is there any significant difference in the performance between male and female students or male and female teachers or whatever? Now you start to have hypothesis. It's just a statement. Again, copy paste from the research question and turn it into a statement. When you say there is no significant difference, this is called what hypothesis? Null hypothesis. No difference, no relationship, no effect. Null hypothesis. If you write it in such a way that is a significant difference, that is called alternative hypothesis. So keep it consistent, just write one type of hypothesis. You don't need to write both. So null hypothesis, yes, you need to write. And if you want to compare between two groups, again, this is just parametric. Your data is interval and ratio. You use t-test independent sample. Independent sample t-test. If you want to compare between 3 or more groups, for example, you want to compare among races, among classes, there are 4 or 5 classes, among states, you have like 5 or 11 states in Malaysia, for example, 14 states, So you want to find, is there any significant difference among the groups? Yes, you need hypothesis. And the proper statistical analysis is called ANOVA, analysis of variance. Okay. If you want to compare before and after, pre and post. For example, if you are doing quasi-experimental, or what's called I forgot the name. Anyway, you want to do an activity and you want to see whether your activity or program or intervention is effective or not, and you have a pre-survey and post-survey, or pre-test and after test. So this is before and after. You will use PET sample t-test. PET sample t-test is to compare performance before and after. Anything that you are doing for your quasi-experimental, and it's easiest to have a data of interval and ratio so that you can use this PET sample t-test. Okay, done with comparison. Next, if you want to find a relationship between two variables, keep it simple for undergraduate, two variables to find if there is any relationship between X and Y. Here, for example, motivation and academic performance, two variables, right? there are two potential statistics to use. Yeah, one is called cross-tabulation and chi-square. The other one is Pearson correlation. So what is the difference? Again, the types of data. Yeah? If your data is nominal and ordinal, for example, motivation and academic performance, both are measured on categorical. Yeah, remember nominal, ordinal, categorical. How categorical? For example, motivation, you put low, moderate, high categories. Yeah. Similarly, with academic performance, you measure their grade A, B, C, and D. Yeah. So when you try to find the relationship, you will cross-tab. Yeah. Cross-tabulation is cross-tabulate. Yeah. Between categories of motivation with categories of academic performance. So if this is the case, the statistical analysis is chi-square to find significant relationship or association. Yeah. But if your data is interval and or ratio, yeah, for example, the same variable but you measure using numbers, yeah, raw numbers. Motivation, you have a scale of items and you total up the score and get a score on motivation. Yeah. And similarly with academic performance, you have raw numbers of marks or CGPA, for example. Yeah. So when you relate two types, two data, interval with interval, then the relationship used statistic should be Pearson correlation. But again, this is parametric. Yeah? If non-parametric, you use Spearman correlation. Okay? Right. And finally, yeah, for undergraduate, we suggest the highest you can go or you may go is prediction. Yeah. Normally, you don't need to go too high lah. Yeah. Okay. So prediction is if you want to examine the effect of if motivation can predict performance, yeah, or does motivation have a significant effect on performance or test score, yeah. So null hypothesis, oh, I forgot to fill in here, yeah. So what is the null hypothesis here? Does motivation have any significant effect on test score? Copy, paste here. Motivation does not have any significant effect on test score. Yeah? Null hypothesis. And the data should be interval and ratio so that you can use simple regression. Yeah? 1-to-1 is simple regression. If you have 1-to-2 or 3, for example, motivation, attitude, 3-to-1, yeah? Your Y is performance, but your predicting variables are motivation and attitude plus stress level, for example. So 3 can predict 1, that is multiple regression. 1-to-1 is simple regression. Okay. So that's about it, yeah. Research questions, matching, research question, objective, null hypothesis, type of data, and statistical analysis. So far, do we have any question here? Swani, do we have any question in the chat box?
I've checked. There's not yet any question.
Okay, thank you.
Belum lagi. Tak ada lagi.
Okay. Right. Next, let's go to analyzing data and interpreting results. Okay, so now we are ready to go into SPSS. Yeah. First, let's look at the software itself. Yeah. Many of you maybe remember SPSS. Yeah. Some of you maybe it's new. Yeah. Nowadays, I heard you can buy this software from Shopee. Yeah. I do not know about the license or whatever. Yeah, but you can buy it. Yeah, or if not, you can install it or buy the proper license software from the IBM. Yeah, Google it uh, in the website. Okay. So before showing the SPSS here, yeah, this is uh, the feature of SPSS, yeah, is by IBM, yeah, statistical SP packages for social sciences. Yeah, is basically like Excel, yeah, with rows of variable at the top and numbers of respondents here. Yeah, basically it's like Excel. So you can have your data first in Excel, then open it in SPSS. Yeah, that is um, possible, doable. Yeah, so if you collect your data using Google Form, for example, yeah, and Google Form will give you the data in Excel format, then you can easily, yeah, open it in SPSS. So that is the beauty of using online data collection. Okay, but let's have a relook at your questionnaire. Yeah, a recap on what variables and values are about. Yeah, so remember the types of data. Okay, when you have your questionnaire, yeah, you need to know that these are the variables. Yeah, your your questions or your items are the variables. So when you enter your data, you set up the what is called? Wait, the variable view or data view. Yeah, the variable view at the below there. Yeah, the variable view, you need to key in, yeah, the name of data or the variables lah. So you can here, for example, type in gender for gender, or if you have lots of questions, sometimes I suggest that you name it as question per se. Yeah. So question 1, question 2, question 3. If it goes on here, nice. If not, you can have, for example, A Q1. A for section A, Q1. Yeah, question 1. Here you have B Q4. Yeah, so for B, you know is section B and it's question number 4, but 4 have A, B, C, D, E. Yeah? So just name it any way as long as it begins with alphabet. Yeah? It cannot begin with numbers. Yeah. Kalau if you put numbers, then it will reject and say something like this is illegal name lah. Yeah. Begin with variable. Yeah. And then we will key in the values. Yeah? The answers to your questions are called values. So all the data are actually values. Yeah, even if it's raw numbers, it's values. If it's the ratings that students circle, then you enter the values. Yeah, so variables and values. Yarhamkallah. Okay, so you on the IBM, you on the SPSS, you get this view. Yeah, and you notice that there are two views. Yeah, one is called the variable view. Yeah, and the other one is called the data view. Yeah, underneath there are two buttons you can alternately click. Yeah, so let's look at the variable view first. Yeah, so here is where you setting first. Yeah, this step is called the defining of the variables. Define the variables. So here you have name. Yeah, name of variables. This is where you type the either, as I said, gender, race, name of school, for example, yeah, or you can just go by question number, yeah, because you have here question number. In label, you can write the proper name of the variable. Yeah, what is the difference between name and label? Yeah, name, you must not have spacing in between. Yeah, for example, if you say, for example, label here test 1, yeah, test 1, you can have spacing. I enjoy this topic, you can have spacing, but here everything must be close, yeah, without spacing. So test 1 would be test 1 without space. Yeah? Name of school, for example, name of school without spacing. That is the main difference. Yeah. Label is not a must. Yeah. If you are lazy or malas nak type ni, it's okay. You don't need to fill in labels. Yeah. You just fill in the name of variable. Yeah? The difference again, if you don't type anything in label column, when you print out or do the analysis, it will use the name here, yeah, Q1, Q2, and so on. But once you have something in label, when you do the analysis and so on, print out, it will use whatever you put in the label. Okay. So once you key in a variable name Q1, yeah, it will automatically on all this, yeah, and you can fill in. Okay, type of data. You double click here, yeah. There is 3 dots here, yeah, unseen, but when you put your cursor here and click, there will be 3 dots, and it will open up a series of list of types of data, yeah. Automatically it will set to numeric for numbers. Yeah, so if we key in numbers, then it's numeric, leave it on. Yeah, unless, for example, you want to key in names. Yeah, name of student, for some reason you need the name of your respondents. Yeah, Sharifah, Muzlia. So for here types, you click the 3 dots and click on string. Yeah, type of data is string. String is when you want to key in alphabets. Yeah. Okay. With no problem. Don't bother about with. Yeah. Decimal is important if you want to have decimal point in your data. Yeah. Normally no, you just put a 0 here. Again, if you click here, there is arrow up and down, yeah, to change the numbers, yeah, or you can just double click and change the numbers here. Yeah? Automatically it will be set to 1 or 2 if I'm not mistaken. Yeah? But for data view and analysis, 1 decimal point is okay. Yeah? So test marks, you want to put 1 decimal point maybe. Yeah. Okay, label, as I say, is up to you. Yeah, it will just make your print out more decorative with all this labeling. Yeah. Values is most important. Yeah, because you want to define what are the answers, yeah, possible for you to key in. Yeah. Why did I forgot to show, yeah, the values, yeah. When you, yeah, here is the 3 dots, see, yeah, 3 dots. If you click on the right hand corner here, yeah, 3 dots, it will appear the table for values. Let me see, do I have it somewhere? Sorry, yeah, I forgot to show this step, yeah. Values, where you in that box you will show, you will type in 1 for male, and then you enter. You will go to the lower box, yeah. And then you type 2 for female.
Tak boleh, saya tengah
and
tengok
then
belajar ni.
it will go to the lower panggil lower
Okay, jom sekejap. Mute.
one, can you mute your mic? Yeah. So 1, 2 ni, where did you get it? You get it from here, okay? From the survey tu, yeah. When students take they are male or female, yeah. Basically you put numbers, yeah, for your values, yeah. 1 for female, 2, sorry, 1 for male, 2 for female, yeah. Interest, 1 for low, 2 for moderate, 3 for high, yeah. If it's open-ended like this, then you don't need values, yeah. Whatever numbers they put in, these are the numbers that you key in, yeah. Rating scale, then it's 1 for strongly disagree, then D for disagree, and so on. Yeah, so these are the numbers for values. So that means we don't type in male, M-A-L-E, female. We don't type the word, we type only numbers. That's why our data is called numeric. Yeah, numbers. Yeah. So those are values. All right. For rating scale, yeah, strongly agree and so on. Don't bother to type each one if you have it properly done before in your Word document. Yeah, you can just simply copy and paste into this label. Yeah, and for values, if you have done for one, yeah, strongly agree, disagree, and you have key in for one. The rest you can just copy paste. What you do is you go here and you click right, yeah, in this box, copy, and then you click in the next box, or you can drag everything down for how many items you have. You click down and then you right click again, paste, and automatically all these values will be pasted. Yeah, so you don't need to do it one by one. Okay. Missing, don't need to bother. Yeah, missing is missing data. So if your respondents skip a question, yeah, or if the data is what you call rosa, yeah, not sure what's the number written by the students or respondents, you can just leave the the data blank. Yeah, and SPSS will read it, will put a dot in that space and read it as missing. Yeah, so you don't need to declare any numbers for missing. Yeah, columns and align, leave it blank. So then you are done with your variable view. Yeah, save it. Yeah, file save as. Yeah, and it will appear here. Yeah, the name of your file, whatever name dot SAV. It's very important because when you are done, you close it and you open the next day, you panic because you couldn't find your data view or output view. Yeah, data is saved as .sav. Yeah, output or result are saved as .spo. I think SPO nanti kita tengok. Okay, SPSS save it as two different files. Okay. Then you are done with your defining variable. You click on this data view bawah, yeah, underneath. And now is steps to enter your data. Yeah, so enter data. If you have manual data, yeah, from documents, or last time it's manual survey, yeah, print out survey. So here you go and enter data lah, yeah. So one row refers for one respondent, yeah. However many you have, towards the end is one respondents. So if you go down here, you can see 23 respondents. Yeah, for each respondent, you key in question 1, 1, remember? 1 is for male, yeah? So this person is male, yeah? And his class is 1, Intan, and his test score is 70.5. See, yeah, all numbers here. And then the rating scale for all the items is he circle 4, 4, 4, 5, 4. Yeah. And the test score is again numbers. Okay. So this is how the data view looks like. Yeah. If you are entering your data manually, remember to save every 5 or 10 data key in. Yeah. Again, if you are transferring from Excel, yeah, you can do it with, sorry, again, I forgot to take a snap of the view, the steps, yeah. You open your data, you have your data in Excel, yeah, and then you open your SPSS first, and then you go to File, Open Data, yeah. So when you go to Open Data, there will be a list of files, Excel, yeah. So you click on that file Excel, and it will out something whether you are you want to do this and that. Just click yes, and then in a second all your data will be transferred here. Very easy. Then you save first your file and you are ready to go. Yeah. If you are not sure, you can always ask me anytime. Yeah. Okay, so you are done with your setting the variable, and then key in the data. You are ready to analyze your data. Yeah. Okay, I think we deserve a break. Okay, dah berasap dah. Let's take a 5 minutes break, yeah, to stretch your limbs and do whatever drinks, whatever. Nanti we come back in 5 minutes time. Thank you. Have a good break.
Thank you, Doctor.
Okay.
Thank you, Doctor.
Don't go away, ah. You still here? Thumbs up sikit. Show me you are still here. Ah, thank you. Nira, Anissa, Azrul ada, Amirul ada, Bashira ada. Okay. So on. Thank you. Thank you. Right. Okay. Let's go now to data analysis. Yeah. I have recorded this. Okay. So we are ready to analyze data, but yeah, first you want to make sure your data is clean. Yeah. So let's talk about data cleaning. What is that? Yeah. Before you rush to conduct any statistical analysis, make sure first that your data is free from error. Yeah. Mistakes made, especially when you key in your data manually. Yeah. So you don't want, instead of 1, the numbers are 0. For example, instead of rating scale 1 to 5, suddenly you have a number 7. Yeah. So that will, of course, make your data skewed to the right or to the left. Yeah. So you want to clean your data first. What you do is simply run frequency analysis on all variables and check if there is any strange numbers appearing in your output. Yeah? So this is where I said I won't demonstrate live SPSS. If not, it will take the whole day. Yeah, I have just copy paste the steps. So next time you can just slowly digest the steps. Yeah, using my screenshots, and of course in Google. Yeah, there are numbers, thousands of views that you can learn how to do SPSS. Okay, so this is frequency analysis, yeah, where you go to the top, variable view boleh, yeah. You go to analyze, descriptive statistics, and you click frequencies. Yeah. When you click frequencies, you get this view like this, yeah, two boxes. So all your variables are listed on the left here, yeah. So you just click one by one. If you are new, you can just click on gender. You click on this arrow and gender will be put here. And you click class, click on the arrow and class will be here. But for data and data cleaning, since you want to clean all data, you can just click at one variable and click shift, yeah, and drag down the cursor until the end and click on the arrow, put everything at once like this lah. Yeah, so everything is put here, done, yeah. Then what you do next is you just click OK, because make sure this box is clicked, yeah. Display frequency tables. That's it. Click here. Then you just click OK. What happened? You will get this output. Yeah. In a second, yeah, all this output will be given. It's called frequency table. Yeah. So what you do is scroll down the page and check each table to see if there is any incorrect data or values. If there is incorrect data, go back to the data and find the incorrect location and make the correction. And after all the data has been corrected, save the new data file and delete the old one, yeah, or save it as a new data file and make sure this is the data file that you will analyze your data, yeah. So for example, yeah, you go lah for gender ni, male and female, yes, yeah, male, there are 32 male students or respondents, equivalent to 47.1%, and female 36 female students equivalent to 52.9%. Yeah. Again, I forgot to show an incorrect data. Okay. For example, for male, suddenly you have male, female, and you have number 3. Yeah. Ada pula non-defined gender. Yeah. Number 3, 1 person. Yeah. A percent is of course like 0.1%, for example lah. Yeah. So number 3 is not supposed to be here. So what you do is you go back to the data view. Yeah. For example, tadi data view, where is it? Like this one. Yeah. And for this column, Q1, gender, yeah, you scroll down this column and find out where is that number 3. Yeah. For example, hey, the first person, yeah, first person, for example, mistakenly you have entered number 3. That's why it reads number 3. Yeah. So what you do is you check the original survey or the data set, yeah, and see this first respondent actually what is the gender. So, oh, you have mistakenly typed number 3. It is actually 1 male. Yeah. So you just correct it to 1 and then you click save here. Yeah. Save here boleh, file save pun boleh. Yeah. So then that's how you correct your data. Yeah. If you find a mistake in the frequency table, go to this view and find the column, yeah, where that mistake is and find out the culprit number and change it. Yeah. So you do that for all the tables until everything is okay. Then you save your data. And now you are ready to analyze your data. Yeah. Okay. So let's start with descriptive statistics. Right. So again, remember we talk about the first section of results, yeah, is to present your demographic details, yeah. So in short, you want to describe your demographic detail, simply conduct frequency analysis to describe your participants. So that's why provided lah, in your survey, you have questions for gender, races, name of school, whatever lah, Alright. So how to run frequency analysis? We have done it just now, this can be done if you want to determine number of respondents based on any demographic details, of course, it's not research question, it's just demographic. It's called descriptive, Now, if your data is nominal, for example, yes, no, male, female, categories of races, or ordinal, level of proficiency, or categories of CGPA, right? So nominal or ordinal data, you use frequency and percentage. Okay, so the step is similar to just now. You go to analyze, descriptive statistics, click on frequencies, right? And you click on the demographic that you want to present. So for example, here is gender, and click OK. And this is what you get, a table on gender. So this one, see, remember I said SPSS has two files, So just now is data. See the logo here. Just now is, wait, sorry. Just now the symbol is like this. This is for data file, There's a red symbol there. And when you do analysis, it will give out this one, blue only, No red color there, output, So when you save this file, if you save it directly here, it will save in whatever name .spo. Okay. I'm telling you this because students often panic when they want to open their files the next day. They will call me and say, Dr. Leah, where is my file? It's gone. I did it the whole day yesterday. So you forgot that it has two versions of files. All right, where was I? Here, So you get frequency analysis for gender, So what you do is you click on this table, click on the right hand side for copy, or you can just click here, copy, and then you copy paste to your document file, chapter 4, So chapter 4, you copy here, And this one I have transformed, copy the output and paste it to your chapter 4, And then you transform into APA format, Our faculty use the APA format. This is APA format where you have 2 lines for the title and 1 lines for the total, The title for table is on the top of the table, Put the title. The title for diagram or charts is underneath the charts. Figure 4.1, don't put on top, put underneath. So that is the format. So again, once you have your data table, remember just one presentation only. For this one, I want to use table. For next one, I want to use pie chart. It's okay. So one presentation and a short description. Table 4.1 shows, refer to your table or name of figure, shows the distribution of gender, and then repeat the numbers inside. Total of 32 students. Kawan dia, the friend is percentage. Remember, frequency, the friend is percentage. Again, you don't need the whole thing here like valid percent or cumulative percentage. You can just delete. The column is not necessary. There you go, you have demographic details of your respondents, how many variables you have lah, yeah. Okay. Right, a bonus, yeah. You can directly copy paste from SPSS output, yeah, the table ataupun charts, yeah. You can click here on top, graph for charts, yeah. But it's not user friendly. I like it better using Word, yeah. So in Words, you can quickly use here insert, yeah. You copy paste first from SPSS, put here paste, and then you click insert chart. Here is chart, yeah. Insert chart, and this view appear, and you can easily choose any kind of charts you want, yeah. Pie chart, column, bar, yeah, histogram, or whatever here lah, yeah. So for example, this is column chart, and there are various types also, yeah. You click OK, and then you can click on the table, and it will give you the Excel data view for you to enter your data, yeah. So from the SPSS output, you just copy lah, yeah. Week here, average, high, and then you put in the numbers 12, 36, 20. As you do this, you will see your charts changing, yeah, accordingly. And then when you are done, you can go to design or format. You can choose the various colors or style of charts. Yeah, so it's very fun to play around. Although there is no marks for colors and creativity, yeah, in thesis, but it's nice to the eyes of readers. Yeah. Okay. Now this is how to write the analysis. Yeah. I am now giving you 5 steps to writing the analysis. You follow this step for all data analysis. You will save. Yeah.
我在听
Okay.
那个啊，你也没跟我打招呼啊，你走了，
Please.
那你都没有关心我什么时候回来，
Fikri, can you
那我还以为你
please
在睡觉呀，我就不
你
去
老把
想你，
人让坏处
switch
想，你
off
这个
the
想。
我没有怎么想，
switch off your mic, please. Fikri ada lagi tak?
A step to write analysis statement purpose， 研究的目的，然后
Yeah.
Wait.
哦，
Yeah.
等一下，等一下，
Want to unmute.
听一下。
哎呀，那干嘛调掉了？
我给你发的那个你看到没？
没看没看。
Saya nak jumpa sudah lah. Mana lah orang cakap kamu ni? Sakit hati lah. Macam pandai. Sakit hati kalau macam ni. Masa tanya. Tanya boleh tak boleh. Tanya dulu.
Oh my. Who can help me to mute everybody ni? Kenapa I tak boleh mute?
都当贵的。
Okay, I have muted you all. Right. Right. Okay. Yeah. Remember to tell me to unmute when it comes to question and answer. Okay. Where was I? Okay. This is the 5 steps to writing the analysis. Yeah. In a paragraph underneath here. Yeah. This is how I do it. Yeah. State the purpose of analysis. Then name this type of statistical analysis. Then you refer the reader to the name of table or chart. and then you highlight the numbers, important numbers from the table and chart, and then you interpret the numbers. So what we have here is, for example, state the purpose of analysis. The first objective of this study is to determine the level of knowledge students have in topics of genetics before giving the motivation talk. Number 2, name the type of statistical analysis. Descriptive, mean, and standard deviation analysis was conducted. As simple as name the statistical analysis. Number 3, refer to the table. Chart 4.1, the name of your chart. Chart 4.1 shows the number of students in 3 levels of knowledge, blah, blah, blah. Number 4 step, highlight important numbers. Then you take the numbers lah. It can be seen that 12 in bracket 17.6% students are considered weak, while and so on. And finally, number 5, interpret the numbers. This result, for example, this result shows that there are a small number of good students, but majority of them had an average knowledge of the topic. There is also a few number of weak students, blah, blah, blah. So if you follow these 5 steps, inshallah, your write-up would be adequately good. Okay, so this is just for descriptive. Okay. Next one, if you want to describe your your data, but your data is interval or ratio. Remember what is the keyword for interval and ratio? There is decimal point, raw numbers, for example, exam marks or score. So your purpose, for example, is to determine the performance of students in genetics or in English. So how do students perform in their tests? You want to describe, and your data is interval or ratio. So the proper statistical analysis to use is mean and standard deviation. But if you are really you want to describe the test performance, who has low marks, who has high marks, the range of deviation and so on, you can add on minimum, maximum, skewness and so on for test performance. So what is the step? Here, analyze, descriptive. Okay, just now we use frequencies only, now it's descriptive. Then you get this view, again you choose test, test 1 and put here, or test 2 you put here, is here. And then you click options, descriptive options. Then this view appear, and you can choose any analysis or test that you want to use. Depending on what you understand lah, Okay, you can ask your supervisor or you can ask me what are proper, But for test, for example, mean, standard deviation, minimum, maximum, variance range, then you can click continue, and then you get this output, So this output again, you can copy and paste in your Word document and transform it into APA style, and again you give the description here following the 5 steps to writing analysis. State the purpose. You are doing your research objective number 1, and state the type of analysis. It's descriptive analysis. Cite, refer to the table. Here I have it, table 4.2. And then highlight the important numbers. Yes, get the numbers. Mean and standard deviation, minimum or maximum, put it in your writing. and then interpret the numbers, yeah, however you want to interpret it based on students' performance. There you go, descriptive statistics, but the data is ratio or interval. Right? Okay. Now, if you are describing items in your statistics, items in your survey, yeah, remember the 5 items that you have to measure motivation, yeah. So you have these 5 items. Let me just remind you, where is it? This one, yeah. So this one, 5 items to measure motivation. So how do you want to analyze it? There are 2 options. Yeah, one, you can analyze item by item using frequency analysis, where you say how many person rated strongly disagree, how many person rated disagree, neutral, and so on. Yeah, this is okay, frequency analysis, if you have small number of items like 5. Okay lah, yeah. So you can make it into 5 different tables, yeah, for frequency analysis. But I don't like so much, yeah, frequency analysis for items. I like to better use mean and standard deviation, because later you can use many more inferential statistics, yeah, using mean and standard deviation. Let's go back to, yeah, items in survey, yeah, to determine the level of motivation, and you are treating it as interval and ratio, and you are using mean and standard deviation. So the same steps just now: analyze, descriptive statistics, descriptive. So what you do is you highlight everything. Okay, this one I'm showing you a trick. Yeah, if you click on the right mouse click, yeah, it will appear this view. Do you want to display variable names or display variable labels? Do you want it? Do you want to see it like this or like this? See, yeah, this one is Q3A instead of I enjoy this topic. Yeah, as I said, sometimes it's easier for me if I have many items to go by question number instead of all these labels I don't remember. Yeah, so you can choose here. If you display variable names, it is like this actually. Yeah, if you click on display variable labels, it will put output here. The view is like this. Yeah, whatever you put in the label column. Okay, right. This is just for viewing methods. Yeah. Okay. So what you do is we want to choose all the items, 5 items. Yeah, 5 items. Put it in this box and click OK. Yeah. Okay, like this. Okay, and then you click options again. Yeah. For describing the items, you just need mean and standard deviation. You want a table like this, yeah? Mean and standard deviation. So you click mean and standard deviation, continue, and OK. Here you go. You get this presentation of table. Yeah? So you copy, paste to your document. Change it to APA format. Yeah, very nice. Yeah, look. Yeah, make sure all items are on the line. Yeah, so it looks nice, presentable. Yeah, nicely put here your subtopic here, kan? Yeah, and your title of table. Yeah, and then again using the 5 steps writing. Yeah, you get all the necessary information. Yeah, okay. Right, senang kan? Very easy, right? Okay, you can do it. Yeah. Just slowly follow the steps. I have it all in this slide. Okay, next, what if you want to categorize raw scores into different categories of level? Okay, meaning in the first place, you have you ask for numbers, yeah, you ask for raw numbers like this one. Sorry, yeah, I just want to remind some people, maybe they forgot what I have shown earlier. Yeah, here, yeah. For example, you have asked for raw numbers for your test score, yeah. But then when you analyze it, you want to recategorize all the marks into low, moderate, and high ranges, kan? Categories of performance. So how do you do this? Yeah. So this is what I meant. How to recategorize? It needs a special step. This is a bonus for you. In case you want to do it, it's called recode. Yeah, step recode into different variable. So first, you need to come up with your ranges. Yeah, depending on how you do it lah. If test score, I think just follow the school or university's range of scoring for grade A, grade B, C, and so on. Yeah. Or if you are doing it for something else, proficiency level or attitude level, positive, quite negative, and so on, you can use the categorization technique. Yeah. So define your range and label it as 1, 2, or 3, and name it as weak, average, and high. Yeah. So have this first, and then this is the step 2. Recode. Okay, before you analyze, do recode first. Yeah, this is transform, recode into different variables. You can also use same variable, but you will lose your raw data. So you don't want to do that. Yeah, recode into different variable. SPSS will create a new column for you. So you get this view, recode into different variable. Yeah. So what you do is you choose the variable that you want to record. Okay, for example, just now test 2, yeah, or whatever lah, Q3, test 1, I think, yeah. Put here and it will appear like this, yeah, Q3. Then you go to output variable and type in a new name, yeah, level. So kat sini dah, this is the new name I type, level, and label it if you want. If not, it's okay too. Make sure you click on change. When you click on change, the name will appear here. Yeah, if not, originally it will appear question mark. Yeah, question mark. So click on change, the new name here. Next, click on all and new values. Yeah, click on all and new values. This one will appear. Then record into different variable, all and new values, and this is where you copy this data. Yeah, I mean sorry, the guideline lah. Yeah, for you to put range 70 to 100 is higher. Range 70, type in 100, and then the new value here is number 3. Yeah? And then click add. Yeah, remember to click add so that whatever you key in here will be put into this box. It's very important. Yeah, so then you can see all the categories here are listed here exactly as you want it. Yeah, so you have 1, 2, and level 3. Okay, you continue. And when you continue, you will see not in your variable view, but in your data view, go towards the end and you will see the new column level. Yeah. So instead of test score, you can see the category 3 or 2 or 1. Yeah. But why does it have decimal point? Because you have not changed it yet. Yeah. So you go next to variable view, go to this new variable level, and you change lah, make the changes to beautify your Outlook. Decimal, change it to 0. Type in the label. And if you want to put in values higher, here is a sample of how the defining of value looks like. Earlier I couldn't find it. Okay, so this is where you key in value number 1, label, week, and then you click add, it will go in here. Value 2, label average, click add, it will go here. Label 3, value 3, label high, click add, it will appear here. So all nicely appear here, then only it will appear here. As it was, there's none. So if you put none here, you did not declare your values. When it analyze, it will appear here 1, 2, 3. Instead of now that you have declare your value labels, when you do your frequencies, it nicely appear weak, average, high. So it's just a matter of appearance. The data is not lost. So here you click OK, then run frequency analysis to get your level of performance. So frequency analysis, we have done it twice already. So you click, you run the analyze, descriptive statistics, frequency analysis, and so on. You get this table. Very nice. So you copy, paste lah. I did not show it. Copy, paste, and write your output there. Okay. So we are done with descriptive. We are now going to higher level statistics. Okay. Let me stop sharing a bit, take my breath and unmute all. Oh. Bisinglah, I cannot I have to mute all. Harus senyap sikit. Alright. Okay, I have muted you all. So if you want to say anything later when I finish, or if not, you can just put your question. Okay. Bashira, do you have a question? Cannot unmute. Asida, Izatul. Hi. Oh, ni macam dalam kelas pula I'm not sure how you have observed your class, not muting yourself. Anissa. Tak apalah, I mute all.
Someone ada cakap dekat chat box doktor yang tak ada soalan bisa pakai.
Yes, okay, thank you. Okay.
Alright.
I mute again
Okay.
Okay. Let me continue with inferential statistics, Okay, right. Now let's go to if you want to compare, If you want to compare between two groups, if you remember, I talk about t-test, independent samples, So the question is there any significant difference in whatever variable performance between two groups? male and female, or Bumiputra versus non-Bumiputra, or high versus lower class, yeah, whatever lah, as long as there are two groups, yeah. The null hypothesis is like this, not null hypothesis, null hypothesis, yeah. And the type of analysis is comparing between two groups. Yeah, make sure your data performance is interval and ratio, then you can use independent sample t-test. Yeah. So how is the steps? Analyze, compare means. Yeah, compare means is all here today. Yeah, compare means use independent sample t-test. This view will appear. Yeah, so there are two boxes here. One is the test variable, is where you put your variable that you want to compare. Yeah, so for example, here is test 1. Yeah, you want to compare, so take from here, put here. The tricky thing a little is this grouping variable, it will have question marks here. Yeah, this is gender, you have taken from gender, Q1, put here, and it will ask you what are the groups. So you click define groups, yeah, and you get this view, yeah, where you simply define your groups as, don't type the male and female, not words, yeah. You just type number, yeah, of the value 1 or 2. Why is it asking this one when you have in fact two groups? Kan? Why do you ask? Why does it ask again? Yeah, because sometimes your groups, there are many more groups. For example, you have 5 classes originally. Yeah? But for this purpose, you only want to compare between class C and D. Yeah, you don't want to compare A, B, or C. Kan? So this is where it's beneficial. So your group 1 would be class C, number 3, for example. Class D is number 4. So you can choose, yeah, from the various groups, but you only want to compare between two groups. Yeah. But again, for male and female, it's obvious 1 and 2. You continue and you get this output. Yeah. So today, now is the time to learn a little bit about statistics interpretation. Yeah. Because you want to write this in your result. Yeah. So you get these two boxes. Yeah. For your result, group statistics, where you have male have 32 males with mean of 64, female 61. Yeah. So if you compare using your eye view, yeah, you would say who has higher mean? Male. Yeah. Male have higher means, therefore male perform better. Yeah, you quickly interpret and conclude that. Yeah. Whereas that is not right. Yeah, you need to do this independent sample t-test or inferential. This one is just apa tadi? Descriptive, yeah. But this is independent sample t-test to really see whether the means are significantly different or not. Yeah. So how to read this table? First, yeah, look at Levin's test. Yeah, this one ada called Levin's test. Because we want to see whether your two groups, male and female, have equal variance or not. Yeah. Okay, I won't waste too much time explaining. Yeah, it's just like whether your two groups are equivalent or not. Yeah. Because for example, if you take one class A and compare with one class Z, of course, class A perform better, right? Yeah. So that is not equivalent. Yeah. Nak to compare. Yeah. So something like that. Yeah. So the way to read is look at Levin's test. If it is not significant, read the first line. If Levin's test is significant, read the second line. what is significant or not, remember? Yeah, this significant test apply to all statistics. Yeah, reading the significance level. Yeah, so you just keep in mind, if the numbers is less than 0.05, then it is significant. If the number is more than 0.05, it is not significant. Yeah? What does 0.05 translate into? 5% of confidence level. Yeah? So from 100%, basically, you want to just be 95% confident that your data is right. Yeah? So 95%, you have 5% too. So 5% over 100 is 0.05. Yeah. So that one is statistics lah. Okay. Back to Levin's test. Yeah. So if it's not significant, yeah. So you see, Levin's test is, this is Levin's test. Significance is 0.355. So 0.355, is it less or more than 0.05? Yeah, more than, yeah. So 0.355 is more than, larger than 0.05. So it's not significant. When Levin's test is not significant, read the first line of the test. Yeah, see the test, there are two results. Yeah, first line, second line. Only for the test. Yeah, other tests don't have this complexity. So read the first line. So you only need three numbers, yeah? This is T values. This is the T test values actually. This is degree of freedom, and this is the significance two-tail test. Yeah, significant test ni. Again, you see the result of T test 0.344. Yeah, again, using this formula is 0.344 less than or larger than 0.05. Right, it's larger than, yeah, larger than 0.05. Therefore, your conclusion should be not significant. What is not significant? Go back to, it's number 2, right? Go back to number 3, yeah, not significant. Actually, the difference between 61 and 64, yeah, you said previously male have higher means. Actually, it is not significantly different. See, yeah, the different conclusion you come to if you just use descriptive compared to you use inferential statistics. Yeah, very dangerous for you just to conclude something based on descriptive statistics. Yeah, so this actually has no significant difference between male and female. Yeah, so what you do, you copy, paste this to your write-up. Yeah, you can transform it to APA format. You can find in Google the APA style or format. Yeah. For this one, I forgot to transform it to APA format. Yeah. But it's still okay to just use this style from SPSS. And again, using the 5 steps of analysis, yes, state the purpose of your analysis, to compare whether male and female significantly differ, yeah. Name the type of statistics, independent sample t-test was conducted, and the result is shown in table 4.5, yeah, name your table, and then highlight the important numbers, yeah. For t-test, you need 3 numbers, the t-values, the degree of freedoms, and significance, yeah. Other numbers you don't need to report, just put it there. Yeah. So it was found that t-value is 0.954, comma, degree of freedoms is 66, comma, and significance equals to 0.344. So interpret this result indicates that there is no significant difference in the test score between gender. Yeah, conclusion. In other words, male and female students have similar level of performance. Yeah, even though our means show male differ slightly, but actually there is no significant difference. Yeah, that is independent t-test. Very important to use inferential. Okay. Now, if you want to compare between more than 3 groups, yeah, performance between classes, and you have classes like 3 or 4 classes, yeah. The same concept of t-test, but now the groups are more than 3. Yeah, so basically the principle is the same, comparing between groups. Right, so compare means when there are 3 groups or more and your data is interval or ratio, you should use parametric ANOVA. Yeah, so what is the step? Analyze. It's all here. Compare means the last one here is one-way ANOVA. Yeah, ANOVA stands for analysis of variance. Yeah, one-way ANOVA. Get this output, and from this table you click on your variable that you want to compare. Is called the dependent variable lah. Yeah, and instead of independent test study, you have to define your group, but with ANOVA it's called factor. Yeah, and you just click move the group that you want to compare, put here. Yeah, so automatically ANOVA will take all groups that you have. If you have 10, it will compare with 10 lah. Yeah, among 10. If you have 3, it will compare among 3. Yeah. Then you go to options. Yeah, one-way ANOVA options, and you click on descriptive. Yeah, it's not click. If it's not click, when you get your output, continue. Yeah. If you don't click that descriptive, this table won't appear. Yeah, and I think that's a loss because you want to see the means for each group like this. Yeah. So I have 3 classes: Intan, Berlian, Zamrud. Yeah. So it lists the means and standard deviation. Yeah. So two output here, 2 tables, descriptive and ANOVA. Of course, the important table is ANOVA. Again, look at the significant test. Yeah. So the 3 numbers you want is F. Capital F here stands for the ANOVA value. Yeah. F stands for ANOVA. DF is the numbers here. 2,65. Yeah. 2 numbers here for degree of freedom. And most importantly, the significance test is this 0.000 smaller or larger than 0.05? Answer yourself. Yeah. So yes, it's less than. Yes, smaller than. Yes, smaller than 0.05. So it's significant. What is significant? This is significant. Yeah, the differences between Intan, Berlian, and Zamrud. So you can safely say Intan has the higher marks compared to Berlian, followed last by Zamrud. Yeah, so there is significant difference among the 3 classes. Right? So you copy paste. Okay. Copy paste there and put. But before that, sorry. If your ANOVA output is significant, yeah. Now the question is, you want to ask whether these 3 groups are significantly different from each other, or there are just any one group that is not really significant. It happens here. For example, okay, 75 and 59 is obviously a big difference. But 59 and 53, yeah, with 4 points, 5 points, is it really significantly different? You want to ask. So what you do with significant ANOVA, you want to do what's called post hoc test. Yeah? If only ANOVA is significant, you conduct post hoc test. If ANOVA was not significant, yeah, for example, here your significant result is 0.0 or 0.1 something, don't need to conduct post hoc. This is your result lah, not significant. Yeah. But if ANOVA is significant, you conduct post hoc. Where is post hoc? The same view, yeah. In one way ANOVA, there is both options, post hoc. Yeah. So you click on post hoc, you get this view. Yeah. There are many statistics on post hoc. Yeah. The most used one relevant is called LSD. Yeah, not LSD the drug. Kan? LSD juga kan? Yeah. Least square. This is least square differences or something lah. Yeah. Okay. LSD, yeah. Or sometimes you can use Bonferroni. LSD lah. Then continue here. Significance level is already stated there. Continue. What you get is this output. Okay. So here is the ANOVA. As I said, if you don't click on the descriptive, that table won't appear. Yeah, just ANOVA table here. Same result. And this is the post hoc test. Okay, give me 1 minute. I want to open the door for my cat. Sorry about that. Right, post hoc test, yeah. So post hoc test again, you can see here, yeah, what it's doing is comparing between two groups at one time. Yeah? It's like t-test repeated. Yeah. So Intan compared to Berlian, Intan compared to Zamrud, Berlian compared to Intan, Berlian compared to Zamrud. Yeah. So what you want to look for is this asterisk. Yeah. If there is asterisk at the mean difference, yeah, Intan minus Berlian, Intan, the mean, yeah, the mean of Intan minus the mean of Berlian, the mean of Intan minus the mean of Zamrud, this is the number. If there is asterisk, basically it's significant. Yeah? If there is no asterisk, this one will be not significant. Yeah? So you can see for all comparisons between groups, yeah, the significance level is less than 0.05. So you can safely conclude that the three groups, yeah, which groups is truly different from each other, all three groups are truly different from each other. Yeah, then only you copy paste all those, yeah, and put in your report. Yeah, post hoc test. Yeah. This is how to write it. You can copy paste lah and just change the numbers. Yeah. Okay, so that is ANOVA. Right. Next one. Let's quickly, sikit lagi. Okay, a little bit more. Paired sample. Okay, paired sample t-test. If you want to compare students' variable before and after or pre and post, remember I said you have like a role play activity or you have what, a cooperative learning activities to test. Yeah, so you conduct this activity. Before the activity, you give a survey on motivation or a test quiz. Yeah, and after the activity, again you give a post quiz or survey. Then you compare whether there is an increase in performance, right? So the null hypothesis is there is no significant difference or no significant increase in students' performance, yeah, after attending or going through the program or whatever lah, yeah. So that's why it's called paired sample, because each person has a pair of scores, pre and post, yeah, or before and after, yeah. So paired sample t-test. Your data is interval ratio. So your statistic, sorry, is not ANOVA, yeah, it's paired sample t-test. So what is the step here? Analyze, that means, yeah, paired sample t-test. Okay, then you get this view. Okay, see, yeah, pair, meaning pair 1, pair 2, meaning at one point you can do simultaneous different comparison, yeah, but of course for first timer you just use one pairing dulu lah, yeah. So you want to compare, for example, pre and post, you label it as test 1 compared to test 2, yeah. Then you can just click OK, and you get this result, yeah. So result again like the test, it has pair 1, test 1 and test 2. So here it shows 62, test 1 before, after 70. Wow, yeah, that's a large increase. 8 points. Wow, yeah, you want to say, yay, there is a large increase. My activity is significant in improving students' performance. Yeah, but wait, that is only descriptive. You want to test it using inferential statistics, right? Yeah. So you go to this paired sample table and you look for your t-value, degree of freedom, and significant test. And again, look at the numbers, 0.08. It is less or more than 0.05? Right. 0.08, yeah, is more than 0.05, yeah. So the conclusion will be there is no significant difference, yeah, even though the number is large, right? The difference is like almost 7 to 8 points, yeah. But statistically, yeah, there is no significant difference, yeah. This is taking into consideration all this lah, yeah, standard deviation, standard mean error, confidence interval, blah, 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 which I don't know how to explain to you, yeah. But sadly to say, the difference is not significant. So your conclusion would be there is actually no significant difference in the test performance before and after the talk, yeah. So although the two means look promising, but the test indicates that there is an increase, but it's not significant. Yeah? So meaning your activity or your intervention does not improve students' performance. Do you need to redo your experiment? No. Yeah, that is the result. That is the result. Yeah, just think about how to explain why your intervention does not help the students. Yeah, there are many reasons. Yeah, maybe you only do it once. The conditions of your experiment was not conducive or not properly long enough. You don't have it like 3, 4, 5 times throughout teaching, right? There are so many reasons. Yeah. Right. This is cross tabulation. If your data is nominal or ordinal, remember I talk about cross tabulation. This is like apa tu? Ultraman, yeah. Ultraman, right? Yeah. When you want to cross tab between two nominal or ordinal, yeah. For example, when your performance is low, moderate, high, and you want to compare between 3 classes, yeah, A, B, C. So the proper statistic to use is chi-square. Yeah. So what you do is analyze. It's under descriptive statistics. It's also under here. Yeah. Non-parametric test. There is also chi-square. Yeah. But let's use it here. Descriptive cross-step. Then you get this view where you can put one variable in rows and another variable in column. So row is here, column is here. Yeah, it's okay to do it the other way as long as you like understand or comprehend the cross tabulation. Yeah. Click OK. Sorry, before you click OK, click on here. Click on cells. Yeah, cells. Yeah. Okay. And then you get this display. Click on observed, expected. I normally use total, yeah, so that you get the percentages. Yeah, if not, you don't get the percentages. As I said, frequency, the friend is percentages. I like percentages. And then you continue OK. Next one, you go to statistic, click this statistics, and you get this view, and you click chi-square. Yeah. All the other statistics here, if it's non-parametric, yeah. But for parametric, you can use chi-square. Continue. Okay, and you get this result. So this is what's called cross-tabulation. Yeah. So level of performance, yeah, is row, and you have 3 categories: weak, average, high. Plus here is column, and you have Intan, Berlian, Zamrud. Yeah, so that's what meant by nominal or ordinal. Yeah, cross that. And in each cell, this is called cell. Yeah. So you just study your numbers. This is why I don't quite like to use cross tab and chi-square, yeah, because there is no clear cut how to interpret it. Yeah? It's just based on your analysis, which cell have high percentage, low percentage, yeah, based on the total and so on. Yeah. So if you see much differences in the cells, percentages or count raw numbers, yeah, you look at the chi-square test. Yeah, the first line, Pearson chi-square. This is the chi-square value, 54.821. Degree of freedom 4, and of course, the look for number, significant test, 0.000. Is it smaller or larger than 0.05? Yay, yeah, larger. So larger, you can say there is a significant association or relationship between classes and performance. Conclusion, it was found that the 3 classes has significantly different distribution of percentages ni, distribution of weak, average and good students in the test. Yeah. So 3 numbers you want to find is chi-square, degree of freedom, and of course significance. Alright, so that is chi-square. 2 more statistics and we are done. Next one is correlation. Pearson correlation, if you want to find any relationship between X and Y. Yeah. So, and your data is interval and ratio, you should use Pearson correlation. So for example, you want to relate between motivation and performance. So with motivation, just now you have 5 Likert scales, items, and performance, you have test score. So what you need to do is first to combine the responses 5 items into one total mean score. Yeah. So to do this, yeah, it's like using calculator, yeah, to compute question 1 plus question 2 plus question 3. You don't need to do it manually. You can use the function called compute. So now I'm going to teach you how to use compute. Yeah, so basically this is the calculator to compute the 5 items, yeah, under one construct. So you use transform, compute variable, and you get this calculator. This is your calculator in SPSS. Yeah? The target variable will be empty. You type in a new word here, motivation, for example. Yeah, and this is your calculator. Yeah, so you don't type it, you take from here. Yeah, so you drag Q forward. Yeah, click and you drag here. Ataupun ni lah, use the arrow, it goes here. Plus, take from here. Yeah, plus, yes, click on plus. And then Q for B, plus Q for C here, plus Q for D, plus Q for E, yeah? Or how many more items you have? If 20, then carefully transfer all the 20 items, yeah? Next, you highlight all the items and put a bracket. Yeah, you can manually type the bracket or you can click here, bracket. It will automatically put the close and the open and the bracket here. And then slash by. Yeah, slash here is division lah, divide by. 5 is the number of items. Yeah, so I have 5 items in the Likert scale survey, so I divide by 5. If you have 10 items, then you divide by 10. This is how you get mean, yeah, average. Okay, yeah, then okay, this is what you get in the data view. Yeah, click on data view. At the end of the column, you will see your new variable called motivation because you name it as motivation. And this is where everybody get the score for their motivation. Yeah? Then only you can do Pearson correlation. Yeah? Then only you do Pearson correlation between test score and the new category, the new variable, yeah, the new motivation score. So what is the step for Pearson? Analyze, correlate, bivariate. Yeah, bivariate refers to by two what? Two variables. Yeah. So very simple. You get this one. You just put the two variables here. Yeah, no matter which one comes first. Yeah, but of course easier. Independent first and then dependent later. Yeah, and then you this is already tick, yeah, Pearson, but if it's non-parametric, maybe you want to click candle tau B of Spearman. Yeah, two-tail and flat significance already tick. Okay, automatically you get this correlations output. Yeah, simple one. Motivation relate to test. So your next task is to interpret the numbers. Okay, Pearson correlation, if you remember from your statistic class, or I will teach you now, there are 3 numbers to interpret. One number, but 3 values to interpret. Yeah. Okay. Where is the value to read? In this table, yeah, motivation relates to test 2. The Pearson correlation is 0.135. Yeah, same thing here. Yeah, it's just a repeat of motivation relate to test to 0.135. So basically, you just need one cell. Yeah. So this Pearson correlation symbol is small r. Yeah, Pearson value small r It refers to the strength of relationship between motivation and test 2. So how do you read the strength of relationship, whether it's strong, moderate, or weak? This is the range of numbers. You can get it from any references. Don't use mine because I don't have proper references here. Just find from a textbook, research method, or from your website, any formal reading on statistics. It will have slightly different range, but it's okay as long as you refer to that citation. So for example here, anything the R value is between 0.7 until 1 is strong relationship. The number range from 0 to 1. Anything between 0.5 to 0.7 is moderate relationship. Anything below 0.5 is weak relationship. So if you get 0.135, what is it? Strong, moderate, or weak? Anybody? Right, type in the chat box. 0.135, is it strong, moderate, or weak relationship? Yes, it is weak relationship. 0.135, almost 0.0. Okay. So this is weak relationship. If this one, another example, motivation relate to test 1, this one test 2, test 1, the number is 0.288. Is it strong, moderate, or weak? 0.288. Yes, similarly, it's weak relationship. So for both results, there is weak relationship between motivation and test 1 and test 2. Okay, right. Now the second value to read is the sign before Pearson value. What is the sign? The sign refers to if you have nothing here, then it's positive correlation. I should have taken example of negative. If you have a sign of negative before the numbers, then it's negative relationship here. So for both of this sample, it is positive relationship because there is no sign negative. Positive relationship. If you have numbers like this, negative 0.288 is negative or inverse relationship. So positive and negative doesn't mean strong or weak. It refers to the direction of relationship. If positive means both variables move the same way. One increases, the other also increases. One decreases, the other also decreases. That is positive relationship. So we can see here between motivation and test performance. As motivation increases, test performance also increases. Logic, What is an example of negative relationship? One increases, the other decreases. For example, stress and performance. As stress increases, performance decreases. So you expect that negative relationship. Age and health, for example, also as age increases, health decreases. That is negative relationship. Okay, so the direction of relationship is important. And the third thing you want to interpret is, of course, the significant test, but no longer look at the R value, you look at the, significant value, So here it's 0.272. This result, significant test is 0.012. Pop quiz here. 0.272, is it smaller or larger than 0.05? yeah, larger than 0.05. So this result, there is no significant relationship between motivation and performance. Okay, but here, even though the result is weak, 0.288, but it is significant, yeah, because it's less than 0.05, yeah, 0.017, less than 0.0105. Yeah. So there is significant relationship between motivation and test. Yeah. See, yeah, even though the strength is similar, weak, but the significant test, one is not significant, other one is significant. Okay. So copy paste that and write the analysis. Yeah. So you can see for this significant result, this means there is a significant, three things you must write. There is a significantly, one, significant, weak, two, the strength of relationship, direction, positive relationship between two variables. Yeah. So if it's inverse relationship, for example, and strong, then your result will be, this means that there is a significantly, one, strong negative relationship between something and something. Yeah, so three values you must state in the result of Pearson correlation. Yeah, one is the significant test, two is the strength of relationship, and three is the direction. Now, only if it's significant, you say there is a significant result and interpret as motivation increases, performance also increases. If it's positive, yeah. If it's negative relationship, then you say something like, as stress increases, performance decreases. Okay. In contrast, if your Pearson correlation is not significant, yeah, like this one, significance is 0.272, is not significant, you don't interpret as there is a relationship, yeah. This always happen, yeah. Error that students write, yeah. They quote the result, R equals to 0.135, p-value is larger 0.05. This means there is no significant relationship. Full stop. No relationship. Yeah. Don't go back to there is weak relationship lah, there is positive relationship lah. Yeah. Because there is no significant relationship. End of discussion. Okay, remember that. Yeah. But don't try. No relationship means there must be an explanation why your data don't show significant relationship. Just need to find explanation. Here, finally, regression. Yeah, finally regression. Then we will end. Okay. The objective is to find if motivation can predict test performance. The same thing, motivation and performance, but only no more relationship. You want to go one step higher. You want to see whether motivation can predict, or is there an effect of motivation on performance. Yeah. So prediction, you use simple regression. What is multiple? As I said, if you have more than one variable here, motivation, stress, attitude, yeah, whatever, predicting performance. Okay, so to make it short, the step is regression, is analyze, regression. There are lots of types of regression, yeah. So you just choose linear regression, yeah. For simple regression, it's also called simple linear regression actually. then you get this table. Yeah. Be careful where you put your variable. Yeah, make sure where is the dependent, where is the independent. So if you have this kind of, this is conceptual framework. Yeah, motivation here is independent or dependent. Motivation is independent. Performance is dependent. Yeah, so here dependent is test 1. Yeah? And the independent is motivation. Yeah, put it correctly. Then let the method be enter, leave it. Yeah, you just can straight away click OK. And you get this simple linear regression output. Yeah, with 3 tables: model summary, ANOVA, and coefficients. Okay, so what numbers to read? Let's look at one by one. Yeah. With model summary, you need to read the R. Yeah, this is our Pearson correlation, but in Pearson is small r, in regression is big R. Yeah, but the number is the same. Remember, 0.288, the significant one. Yeah, 0.288. So here is 0.288 Pearson correlation, and this is to interpret that is a weak relationship between motivation and performance. Okay, right. Next one, you go to ANOVA test to see if the effect is significant or not. Yeah, again, like ANOVA table, capital F, degree of freedom, and significance. Yes, 0.017. Yeah, significance, which is less than 0.05. So there is significant prediction. Yeah. And how much can you predict? How much can motivation predict the variance in test performance? Yeah. This is confusing sikit lah, ya, for us not statisticians, but you can copy this way of writing and just carefully plug the numbers from your table. Yeah. So R squared is the variance of motivation that can be explained, the variance in performance, yeah, the variance in performance test that can be explained by motivation. And how you do that? You take the numbers, 0.083 times 100%, you get 8.3%. Yeah? So your sentence would be 8.3% of the variance in test can be explained by performance. Yeah, I will show you the write-up a little bit. And then this table, the third one, coefficients. This is the regression equation if you want to write it. Yeah, some supervisors want it. Y equals to A plus B X. Yeah, so Y is the dependent variable. So it's the performance test, and X is the independent variable. Yeah. And A, B, you just plug the numbers from A is the constant here. B is the independent variable. Yeah? And you can check your dependent variable is -1. Yeah? If you see your dependent variable here is motivation, then be aware, yeah? You have mistakenly keyed in the table just now. Yeah. So you plug in the numbers. A 31.069 here, and B is 8.421 here, and write the test and motivation. Yeah. So basically, for every one increase in test, you have 8.4 to 1 increase in motivation. Like that. Yeah. Okay, and this is how to write the analysis. First, you talk about the table model summary, yeah, relationship, and then the variance, 8.3% of the total variance in test can be explained by motivation, yeah. And then you go to second table, ANOVA reports that the test is significant because it's less than 0.017. And then the coefficient, the equation, if you want to do it, you can just write it down. Okay. There are a few other ways of writing the analysis, yeah, but this is just one way of doing it. Okay, I am done with sharing with you steps of doing analysis, especially for undergraduate. Yeah, normally we expect you just to go up until regression, not more. Yeah, but of course with PhD and master students, they can go to other kinds of structural equation and so on. Yeah, that one you need another workshop. Okay. Now, allow me to just quickly talk about reliability tests. Yeah, I'm sure some of you want to do reliability tests, especially if you are doing questionnaire and you want to see whether your items, yeah, are consistent. Yeah, and the scale is unidimensional. Yeah, referring to this. Go back to our sample of survey. What is reliability about? Oh, ya kan? Yeah. So you say this is 5 items measuring motivation. Yeah. So you do two things. If you develop especially your own items, one, you do content validation, show your items to an expert in the field and let him or her professor, whatever, rate, evaluate whether the items really measure motivation. Yeah. And the other second thing you can do is you do a pilot test after you do the content validation. You do pilot test, and even the actual data you can do reliability test. You enter into SPSS and do reliability test to see whether all these 5 items consistently or reliably measure the same construct motivation. Yeah? So how to do that? Step is okay, sorry. Yeah. So you want to get something like that, right? Like this. Chromebook Alpha is the name of the result. Yeah. I'm sure you have learned about this or remember. Yeah. So for example, your construct is product risk. You have also financial risk, time risk, and service risk. So under risk, you have 4 categories or dimensions or sub constructs lah. Yeah. And for each type of risk, you have different number of items. Yeah. So you want to see whether all these 4 items really measure product consistently, 7 items measure financial and so on. So you need to see the Chromebook Alpha. Yeah. And there is range for the numbers to interpret similarly like Pearson correlation. Yeah. So you can find these references from any citation, a good one, and you can put in your chapter 3, yeah, to interpret that if your Chromebook Alpha is above 0.8, normally is good and excellent, meaning your survey is reliable, highly reliable. Yeah, if you get anything between 0.6 and 0.7, acceptable, but it's below 0.5, 0.6 even, yeah, below 0.6 is questionable, poor, or unacceptable. You need to change your items, yeah. So the steps is analyze, scale, reliability analysis. Yeah? And what you do is you copy paste all the items in this box. Now remember, not copy paste all the items in your survey. Yeah? Copy paste items set by set according to the variable. Yeah? If you have, for example, question 1 until 9, actually measuring 1 to 5 is motivation, 6 to 9 is attitude, for example, then don't lump it together. Yeah. Analyze first 5 items for motivation. Next one, the 4 items 6, 7, 8, 9 for attitude. So don't make the mistake of analyzing everything together. That is wrong. Okay, so just put the items that measuring 1 construct here, and then the model is alpha. Yeah. Click on statistics and you get this table, yeah, and you can click item scale if item deleted, and ask for correlations, continue, yeah, and you get this output. Yeah, so this is where you get your Chromebook alpha. Yeah, so for example, 5 numbers of items measuring motivation, the alpha is 0.855. Yay, that is quite high. That means your items are reliable. You don't need to worry. You can proceed. Yeah. But if, for example, your Chromebook alpha is 0.5 something or 0.6 something. Yeah. So what to do? Yeah. You go to this table, item total statistics. Yeah. I forgot to get this example, yeah. Okay, so basically you need to read to study all your items and see, for example, which item if if deleted, your Chromebook alpha will increase. Yeah, so here your Chromebook alpha is 0.855. So if you delete item 1, your Chromebook alpha goes down to 803. That means don't delete this item. Item 2, if you delete, your Chromebook alpha is reduced to 0.7 something. Don't delete this item. Yeah? So you go on. So for example, here is 0.6. And if you delete item number 1, your Chromebook alpha is increased to 0.7. So you want to delete item number 1. That is how to study the item analysis if you get a Chromebook alpha lower than 0.7. Normally, yeah, that is the normal acceptance for a good reliability test. Okay. So you can write your reliability output, put it in chapter 3 under instrument. Yeah. So you can copy lah, yeah, how to write this. And that's all for chapter 4. Okay, yeah. And quickly, chapter 5. This is just an outline for you, yeah, reference. Again, is introduction to the chapter, a short one, half a page, yeah, or just 1 paragraph. And then you can write 5.2 summary of an overview of the result. Yeah, some people put just summary here and discussion in the next section. Yeah. Some lecturers want you to combine summary and discussion. Is okay, up to the supervisor. You can ask them. Yeah. Not, you can do it one by one. Summarize first and then discussion. Discussion is where you take back your literature citations here and compare which one is similar to your findings, which one is in contrast, and maybe you want to discuss why and how and so on. Yeah? Discussion. Implications is how the findings may be important in terms to the policy of language learning, for example, of STEM, whatever, yeah, to practice, to theory, if you are doing theory, and for future research. Okay. Recommendations is for further research, yeah, how other people can do this study better in terms of larger sample size, or instead of quantitative, you must do qualitative also, all sorts of recommendation. Yeah. And the conclusion, of course, 1 or 2 paragraph to the summary of the chapter, and maybe you want to do one conclusion for the whole research. Okay. So remember, in chapter 5, no more numbers, yeah, no more data. Yeah, you just want to write and write and write. Here is another view of it. Yeah, discussion, recommendations. Yeah, even in summary of findings, do not have numbers anymore. Yeah, just translate. If high numbers, you can translate to majority of students. If low numbers, you can say only a few students. Blah blah blah. No more numbers. Numbers only in chapter 4. Yay, that's the end of this summary. If you, inshallah, you can do it so that everybody who needs to graduate can graduate this semester. Yeah. So now, if you have any question, you can ask me, right?
Assalamualaikum, Dr. Sharifah Muzlia, sorry. I'm actually Dr. Siti Nuraini from Pusat Asasi.
Oh, okay. Hi, doctor.
Because this is my first time supervising student from UiTM, previously from Taylor's. Okay. All right. Just hari ni first time saya ikuti klinik yang diberi, and I think this will be the last one, isn't it?
Yes.
Okay. Yeah, luckily. But this is sort of conclusion to the end of the AE punya report, or
Yeah, and especially if the student is doing quantitative, yeah, but we also had a session on qualitative and previous chapters. But don't worry, we have a link to the Google Drive. I'm going to paste it in the chat box now, and you can.
yeah, just now I can see Dr. Nur Hayati sharing
Yes.
the link. Is that the link that we can
Get all the materials.
get all the
slides
materials,
and-
including this recording? If I'm
Yes,
not
inshallah.
mistaken.
Yes.
This recording, today recording will be there, isn't it?
Yes, I will put it there.
And also the other recording yang you pernah buat. Right?
The previous one given by different lecturers. Yes, we have.
Ya, yang hari tu listed, right? So I tak sempat nak tengok. Luckily today on Saturday, and attendance saya tak perlu ni kan?
Attendance just for students. But you can just fill in, yeah, just to give us a record of who attended the.
Alright, okay. So just wanted to know the slide also will be in the GD, isn't it?
Yes, we will share with.
Okay, Doctor, boleh tak you go back to the mana ni? Yang chapter 5 tu, saya ada soalan.
Okay, let me.
I'm not sure about the student.
Okay, it's okay. Yeah, chapter 5.
Yang outline yang before this slide.
What?
Yang ni just the outline, right? Yang kena ada dalam chapter 5. Am I?
Yeah.
Right? So yang
Yes.
marks ni goes to this chapter 5. 1 mark, 8
Betul.
marks.
Betul. So
Maknanya,
if you refer to the evaluation sheet, I'm not sure whether we have given it in the email or not. So for chapter 5, the total marks is 20. So
20.
less
Yang
than
chapter
20.
sebelum-sebelum tu ada marks juga.
Ada marks juga, yes. So
Oh,
so ada dalam, it is in the evaluation sheet.
alright. So this is the guideline lah, how many pages that they should have for the introduction in
Yeah.
chapter 5 and all. This is kind of, let's say we as a lecturer, we wanted to have a view of what they have done, then we go to the chapter 5 first and see. Then if not, and then after that we can go back to the chapter 1, 2 and 3, right? To look at what they have done. So for us as a lecturer, okay, kita just tengok apa student tu what type of apa tu tadi semua research question diorang, and tengok type of what we call that just now yang diorang
Set
guna test and
analysis.
all that.
That's yes,
Analysis,
yes.
yeah, types of analysis and so
Right.
on, right?
Uh-uh.
Okay, apa saya nak cakap, saya baru supervise this semester. I tengok ada some student they don't really understand macam research question and all that.
Yeah.
And,
That is
research
normal.
objective and research question. Now kan dia mesti match, right? You ada cakap kan?
Yeah. So that's why because they learn about research methodology in semester 5, and this is like semester 8, and of course lah there will be students who forgot or don't do it right. So that's where we as supervisor can help them to make corrections lah to whatever they are doing.
Sebab my student currently, I think diorang tengah buat dekat apa tu orang panggil internship dekat
Practicum.
practicum. Okay, practicum.
Yeah, school practicum.
Apa tu baru semester 7, right?
Semester
Semester
7.
8 baru diorang kena hantar benda ni, right?
Betul.
Okay, hopefully I can guide them on this lah.
Yes.
Comparing to tailors, macam student diorang dah satu semester je, lepas tu they can come up with all those things, you know.
Yalah, betul.
Tapi bila saya tanya student yang tengah semester 7 ni, they have no idea. I don't understand why.
Yeah, if they say they have no idea, then they have not paid attention to what they have learned before lah. Because kan.
Yang nak design and all that, I kata nanti you nak guna apa? Dia kata tak tahu lagi doktor, mungkin macam ni. That's why I nak tengok apa yang ada dalam ni. So that's why I join this one. I enjoy your talk. Very nice. Very well.
So please be patient with the students lah. Some of them are really like out of space. Sorry students, yeah. Some of you really like tengok kan malu kita dekat lecturers yang baru masuk, macam like we have never taught you anything, but I think some students.
Yeah, you guys did well, and I don't understand why the student cannot catch up with the things.
Yeah.
And then satu benda yang saya perhatikan, I'm so sorry, bila you unmute everyone, ada suara kat belakang. I think it's not proper way of doing it lah. If I'm not mistaken, diorang ni semua education student, right? Education meaning that they will be a teacher, so you know the impact of it.
Yeah, I do not know why today is quite a horror. Ramai orang lupa nak mute dia punya mic ya.
Tak conducive lah, I think. I mean, this is really helpful talk. I think yang boleh bantu diorang, they should be more serious on this lah. Anyways, good job, doctor and everyone.
Okay, thank you.
Thank you so much.
Alright, let us see if we have any other question.
Dr. Lia,
Yes.
there's a question on the chat box. Do you want me to read it for you, or the person who asked wants to read it?
Okay, maybe you can read it.
Okay, this is from Ifa Nabila. Salam Dr. Lia, kalau RQ kita is to find if the teacher's role influence students' academic performance, soalan ni to predict ke or bukan ya? Influence kena replace dengan predict.
Okay. The word influence, yes. Can mean predict also. Influence, affect, effect, predict is the same thing. Yes. So you can do regression. Hmm. Okay. If you want to do just a relationship, then to find relationship between lah, yeah. But once you use the word influence, yeah, it sounds prediction. It's not relationship. So you need to change to analysis, prediction. Okay, thank you. Other question? I do not know why today everybody is like
Saturday mood kot, doktor.
itulah selalunya tak macam ni sangat. Hari ni macam pelik sangat. Okey, tak apa. Siapa lagi ada soalan?
Assalamualaikum, Doctor.
Ya, waalaikumsalam. Fazrul.
Are pilot tests considered as reliability tests as well?
Yes, pilot test. Okay. The purpose of pilot test is to test your instrument. Yeah. So it can be two ways. Yeah. One is you just test out the whether students understand the question, what questions are difficult, or you need to change words. Yeah. In terms of doing experiments, for example, what are the ways of activities you need to change, the time or the place, whatever. So it's more like a qualitative evaluation lah. The second thing you can do, especially if you do survey, is do the reliability test. So reliability test will see whether your items consistently measure the construct. Okay, Fazrul?
Good. Thank you, Doctor.
Welcome. Any other question? Ashira, you have a question?
Bisa dan dapat ha.
Doktor,
Yeah.
boleh saya dapatkan your contact number in case?
Okay, yeah. I will write it in the box, yeah. Dekat
By
slide
the way,
pun
the
ada juga.
link, sorry?
Yeah. Okay. Link.
By the way, the link rakaman AE, klinik AE tadi tu saya dah share dekat group practicum AE ED249Z, okay? For you guys.
Oh, okay. Alright.
Sebab ada yang bertanya minta link for today's
Okay.
recording.
Yeah, sure. Boleh, insyaAllah.
Thank you, Doctor.
Okay. Yeah, sorry just now I cannot, tak tahu pula I punya ni tak boleh ambil certificate. Selalu boleh. So that's why I mute
I
everybody.
think some student asking you to mute everyone, tapi I rasa kalau diorang nak cakap, diorang boleh unmute themselves, I guess.
Kan.
Yeah.
Anybody else have question?
No, Doctor. So far, it's very informative.
Okay, thank
I
you.
understand everything so far.
Good.
Thank you
So
so
now you can
much.
quickly collect your data and start analyzing. And if anybody has any question, you can always text me WhatsApp. Yeah, inshallah I will help. Okay, if you
Doctor,
don't.
sorry.
Okay.
Student pada semester 7 yang diorang collect data, right? And then semester 8 yang diorang analyze everything.
Tapi kan doktor, you need to, sebab ini confusing sikit lah. We have two groups, one semester 7, one semester 8, yeah. So you need to ask your student whether he or she is graduating or not. The keyword is dia graduate semester 7 ke 8.
Oh, okay. Kalau diorang
Yes.
graduate semester 7,
Ada
diorang
juga
kena-
kalau semester 7, then they need to submit semester 7 lah. And in that case, they need to collect and analyze everything this semester lah. In case, yeah. Okay. If they are semester 7 but they are graduating semester 8, then it's okay. It's up to you. And it's up to student punya kerajinan lah. Kalau yang rajin tu semester 7, they still want to finish everything, get it done and over with, boleh je.
Sebab sekarang diorang tengah buat praktikum dekat sekolah kan.
Kan, sometimes I advise them masa research method, kalau masa praktikum you nak collect data terus pun, why not, lagi senang kan. Kan,
So
provided
they are told so to do that in
boleh.
semester 7 lah.
Yes,
Kan,
yes.
advisable, right? Doctor, you ITM mana Sorry, sorry.
Kita Puncak Alam.
Puncak Alam, okay doktor.
Alright, so thank you very much everybody for being here with me. Yeah, inshallah I will upload the
Thank you so much for your
recording.
sharing.
Yeah. So I see you whenever. Yeah. Thank you so much. Sorry for all the complications today. Assalamualaikum and have a good day. Bye.
Thank you, Doctor. Thank you so
Waalaikumsalam.
much.
Welcome.
Waalaikumsalam. Thank you, Doctor.
Welcome. Bye. Welcome. Thank you, doctor.
Bye, Doctor. Take care.
You too.